So on the argon plane below, sketch the locus of z take away 1 take away I is equal to z plus 1 take away 3I. So we know this type of thing is a perpendicular bisector. We've just got to make sure we triple the marks here. So that's z take away 1 plus I. And then remember, that's the best way to write it. And this one will be z take away negative 1 plus 3I. So 1, 1, make sure you get that onto the graph, and negative 1, 3, make sure you get that onto the graph as well, and it should be fairly clear that the midpoint of that is just there. Now, the gradient of that's negative 1, so we want something with a gradient of 1, which means that it's going to go through negative 2 here. So it's going to go like that, and then I'm not happy with the way I've drawn that. So let's just get rid of it. And I'll give it one more attempt. There's no point in me spending ages on this. Obviously, I'd just use a ruler if I was in the test. And so that's that. And I might do a little indication here, like so. So I've put on all the points I think I need to get the 3 marks. And okay, so now we're moving on to a second part. Well, this one's a circle, isn't it? So let's think about that. So z take away negative 2 take 2I less than or equal to 2. So that's going to be a circle of radius 2, which is centered at negative 2, negative 2, so sort of here. So not that easy. I've got a circle drawing tool on here, but it's not that easy to get it in the right place. So let's just do the best I can, freehand. They have to look reasonably good. You can't really get away in the exam with something that looks really non-circular. So it's worth taking a little bit of time on this. I think I'd probably get away with that. So that's the first one. Arg z is, well, we know that we've got to put on negative 3 pi by 4. So negative 3 pi by 4 would actually go down there through the radius. So that's going to go like that. And then real z is less than or equal to negative 1. But remember, real z in this context, you will just say x. So x is less than or equal to negative 1. So that's, oh, wrong drawing tool really. So let's just get rid of that and try it with the line tool. And so that's just going to be x equals negative 1, like so. And then we want to shade a region that is within the circle to the left of our vertical line and has a modulus that's more than negative 3 pi by 4. So that will be this side. Remember, back here they're more negative. So in actual fact, the region that we want is this region just here. So that's the one we should shade. Determine the minimum possible value of real z within the shaded region. Now this is actually genuinely quite difficult. It also is something where this 1 mark is really quite contingent on you having got the other bit right, because if you actually shaded this region or this region, you simplify it too much to actually get that 1 mark. So what I'm going to do, this is obviously the point we're after. Let's form a triangle here. Now we know that this is 2 because we know the radius is 2. And we know that this is pi by 4 or 45 degrees. So if we're after this distance just here, which I'll call A for the moment, we know that sine 45 degrees is equal to A over 2. So A is going to be 2 times sine 45, which is 2 times root 2 over 2, which is root 2. Now think about this. It's already 2, and then we've got the other root 2. So it's negative 2 plus root 2.